be them aliens. Seriously. Where are they? Are they out there? The question of whether or not we are alone in the universe is certainly a doozy. Among other things, it determines how we see ourselves, how we see the rest of the cosmos, and how we see the future. Until 1923, it was widely thought that there was just one galaxy in our whole universe. That thought, of course, was eventually disproven, and the universe is huge. Take the Hubble Deep Field image. Look at this picture. Every little speck, a galaxy massive in size, at only 6/100ths of the sky. That is tiny. Take this quarter. Hold out your hand in the field of the area of the field of view that this quarter is taking up is the area of the sky this image is looking at. There are probably around 100 billion stars per galaxy pictured here. That's pretty impressive, but it pales in comparison to the number of stars in our universe. According to the European Space Agency, there are approximately 1 × 10 to the 24th power stars in the universe. That is a 1 followed by 24 zeros. That is enough stars that if you turn each star into just a cubic yard of Earth, that would be enough dirt for 706 Earths. And by the way, that's just 100 Earths pictured here. And you can probably already tell, but this universe can be a confusing, terrifying, spectacular, and crazy place all at the same time. I'd say the only thing it is not is boring. So, as a human race, we should take an interest in it. Today we will be investigating the Fermi paradox. To do this, we will explore the Drake equation, the mathematical statement that is one of the main bases of the Fermi paradox. We will then look at the paradox itself, and finally, a couple possible solutions to the Fermi paradox. So, let us begin. I hope you like variables, because I have an equation with quite a few variables for you. This is the Drake equation. The Drake equation is n equals r to the subtext of star times f to the p times n to the e times f to the I times f to the L times f to the C times L. It was created by a scientist named Frank Drake for the first meeting of SETI, or the Search for Extraterrestrial Intelligence. The equation, in its slightly more understandable form, goes as follows. The number of civilizations in our galaxy with which communication might be possible equals the average rate of star formation times the fraction of these stars that have planets times the average number of planets that can potentially support life per star that has planets times the fraction of planets that could support life that actually go on to develop life times the fraction of planets that support life that actually go on to develop advanced life times the fraction of civilizations that develop a technology that releases detectable signs of their existence into space times the length of time for which such civilizations have released detectable signals into space. Don't worry, there won't be a test after my speech. According to Adam Frank, professor of physics and astronomy at the University of Rochester, we can tell how low the probability for us to be the only civilization the universe has produced is. We call that the pessimism line. Humans are likely to be the sole advanced civilization in the universe if the likelihood of advanced life arising is 1 in 10 billion trillion, roughly equal to the chance of flipping a coin and getting heads 89 times in a row. This brings me to the Fermi paradox. It is, in essence, the question you're probably asking yourself. If, according to our math, there are probably billions of alien civilizations, where are they? It was originally thought up by the scientist Enrico Fermi. He knew that with just rudimentary rocket technology, it would only take 10 million years to colonize the galaxy. The universe is an estimated 13.8 billion years old. That's plenty of time for spacefaring aliens to spread. So, where is the evidence they ever did? Nowhere. Over 50 solutions to the Fermi paradox have been proposed. But don't worry. Instead of regaling you with all the details from every single one and going for the record of longest speech ever made, I'll tell you just 3. The Great Filters theory originates from a popular 1998 article by Robin Hanson titled The Great Filter. It is the theory that there is some natural factor, something about the nature of life and the universe itself that makes intergalactic civilization extremely difficult to achieve. Perhaps all life destroys itself soon after it invents nuclear weapons. Or maybe there is some step on the road to advanced life that is much harder to accomplish than we think. Most differences between each possibility do not matter. But there is one difference that does matter. Whether the Great Filter lies ahead of us or behind us. If the filter lies ahead, this means that at some point in the future, because of the filter, we are almost certainly going to face probable doom. If it lies behind, we can look to the future knowing that we were the extremely lucky species that got past the filter, and now the universe is our oyster. Now, let me put on my tinfoil hat for this next segment of the speech. What if we have been visited by aliens? On September 18th of 2019, the United States Navy confirmed that a video that had been leaked from them in 2017 was indeed real. It showed a UFO darting around the sky, moving to the left, out of frame, too fast for USN sensors to reacquire it. I am not saying that these are aliens. We don't know. But there is no evidence to suggest they aren't aliens. No matter what they are, there has to be some explanation for them, extraterrestrial or otherwise. Additionally, since the first reports of fiery discs over Egypt in 1440 BC to today, tens of thousands of UFOs have been reported. If one person reports a UFO, maybe they're crazy. But tens of thousands, there's something going on. The final proposed solution I'll share with you today is a bit odd. It is the theory that every civilization eventually develops virtual simulations so good that they can't tell the difference between the simulation and real life. VR technology is advancing at breakneck speeds. It is not completely out of the question to see this happen. You may ask, what does this have to do with the Fermi paradox? The answer is, maybe we live in one of these simulations, and our ancestors who lived in the real universe met real aliens and were so utterly terrified by them that they put us in these simulations where extraterrestrials don't exist to escape them. The thing that's truly offsetting about this is that we will never know if it's true or not. As previously discussed, this proposed simulation is so good that we physically cannot tell the difference. If this is the answer, we simply will never know. We'll forever look upon the empty stars, wondering why they are so empty, not knowing that we made them that way. So this brings us full circle. We have established the statistical probability of alien life, how this probability, combined with the lack of evidence of any alien life, form the Fermi paradox, and explained a couple of the many possible solutions to the Fermi paradox. But the question still stands. Where be them aliens? We may not have answered this question today, but by opening our minds and talking about it, we've come one step closer. Thank you.